Hi everyone, good morning or good afternoon, good evening, depending on where you are in the world, which time zone you're joining from. I'm Jerome Petazzoni, and today we are going to talk about Kubernetes development environments. So I'm going to explain what it is and why maybe you might need one and what it could do for you. Quick intro about myself. So I'm Jerome Petazzoni. A long time ago, I worked at Docker for 7 years, like from 2011 to 2017, approximately. And so in a way, it's kind of exciting because now it's been a longer time period where I haven't worked at Docker, like, I don't know if you see what I mean. I don't know exactly how to use words to describe that, but I worked 7 years at Docker and it was more than 7 years ago. So finally. So what I do now is that I do teaching and consulting on Docker, Kubernetes, and cloud native technology. And sometimes that gives me excuses to dress up as a pirate and go on conference stages. That we did that a couple of years ago at KubeCon Paris. That was pretty great. Okay, so enough about me. Let's talk about Kubernetes development environments. So first, why would we need a Kubernetes development environment? Well, if you work with Kubernetes, you know that when you try to get the logs of a complex controller, instead of just trying to get the logs of a container, let's say that I want to get the logs of all the pods of kubeproxy. So kubeproxy is a system component. It's responsible for managing connections to cluster IPs and node ports on most clusters. Let's say that for some reason I want to see the logs of all my kubeproxy pods. And well, it's kind of not great because what I can do, for instance, like if I'm here, let's go to one of my kind of clusters here. So a nice cluster with 4 nodes. And if I look in kubesystem, I see 4 kubeproxy pods. So I go there, and if I try to get the logs, by default, this is going to give me the logs of one of the kubeproxy pods. So if I want to see the logs of all these kubeproxy pods, like aggregated together, I have a bunch of options. I could say, hey, give me specifically the logs of that daemon set kubeproxy. But at first it looks like it works, but really it doesn't, because here it's telling me, hey, I found 4 pods and I'm going to show you one of them. Okay, so we could use a selector. For that, I need to build that selector, but by looking at the labels that the kubeproxy pods have. Okay, there you go. That one seems a pretty good candidate. So now I can put -- selector Kate's proxy app kubeproxy, and that's going to give me the logs of all these pods. Or I could just use a better tool for that. I could do stern kubeproxy, and that's going to automatically give me the logs of all the kubeproxy pods. Plus, one of the advantages of Stern is that if some of these pods bounce, like, if they get deleted, recreated, if there is a rolling update or whatever, Stern is going to detect that and keep showing me the logs. So I was just like one little example of a very simple, straightforward, common operation, view the logs of a daemon set, and showing how if we have the right tool, it's going to be so much easier. Excellent comment in the chat, like, what about K9s in that case? I'm going to be honest with you, I don't know if K9s would give us a nice way to do that, so let's give it a shot. So yeah, I could easily see the logs of one of the kubeproxy pods. However, Can I see the aggregated logs of all of them? Not easily. There might be a way, but I'm not familiar enough with K9s. Maybe I can with a plugin or something like that. But you know, that's an excellent remark as well. Maybe I don't like to work with kubectl that much and I prefer K9s. This is all going to go in the direction of Kubernetes dev environments. So what I was trying to show here is that, you know, I can either struggle a little bit with kubectl or I can just use Stern and immediately have my logs. So, you know, when you work with Kubernetes, I expect that you're going to start with, I would say, the usual suspects, kubectl, Helm, Stern, K9s, yep, maybe Docker because you want to do some Docker builds and use Docker Compose and things like that. You probably want completion because completion is awesome. You know, like I can do get pod kube, and when I hit tab, it's going to complete for me. So kube proxy, you know, g up. So that's going to save me a lot of time. Maybe I also want to have an alias because actually that's what I was doing here. You know, instead of typing kubectl get pods, I just do key get pods and there we go. And as you might notice, we even have colors here because I'm using something called kubectl. I have kind of like hooked it on my K alias. So when I use K instead of kubectl, I have colors here. And when you see that output, you might think, well, what's the big deal with these colors? It doesn't seem very useful. But if I try, for instance, create deployment hello with an image that does not exist, then we are going to see the error message here in red, which is going to help me to notice that something's wrong. You know, it's not like game changing, but everything that helps me to notice errors a little bit more, for me, that's useful. Oh, great question. Like, what's the point of showing all the logs together? That was just like one example of something we might want to do. So in that case, and I agree with you, by the way, you're absolutely right that on a good production cluster, we should absolutely send the logs to a log aggregator. Why? Because, for instance, if you have a deployment and you scale it, you know, to 3 pods, you scale up to 20 pods, and then you scale back down, and now you want to see the logs of the pods that you scaled down. Well, you can't. I mean, technically, you could go on the nodes and kind of like go in the right place in the file system, and if you're lucky enough, the log might still be there, but you can't really do that in prod, especially if your cluster was itself auto-scaled, so you were adding and removing nodes. Once a node is gone, the logs of the pods on that node are gone as well, which is why we absolutely need a log aggregator in production. 100% agreed. But in some scenarios, if I'm in a dev environment or a staging environment, maybe I'm not going to set up a log aggregator for that because it's actually going to hurt my velocity. You know, if I just want to see the logs live as I do like HTTP requests because I'm debugging an issue, if I need to wait, you know, for the log to go to the pod and then go to the logging platform and then show up on the logging platform on the other side, that's kind of a huge waste of time. So Stern and kubectl logs, they have their usefulness as well. Okay, so this is, I would bet that this is the first tools that most of us are going to put in our Kubernetes toolbox. And you know, that's going to be maybe you recognize that toolbox here, that's the classic IKEA toolbox, like the first time that you move into your own place and you go to IKEA to buy a bunch of stuff, and typically you get that box. I don't know how much it costs now, but back in the days it was like maybe $10, and it's not great, but at least you have a good screwdriver, a hammer, like etc., etc. Now, after a little while, after some time working on Kubernetes, or after some time doing some serious home improvement, you end up with a toolbox looking like this. So for instance, you want kubeps1. Kubeps1, that's the thing that adds the custom prompt here to remind you which cluster you're working on and in which namespace you are. kubectl, which is going to help you switch clusters like this. So you can like select which one you want. KNS to switch namespaces as well. kubectl, which I mentioned already. And of course, there are a lot of tools that are not specific to Kubernetes, but that we often want to have with us. You know, curl or HTTPy, which is something to send HTTP requests and to APIs and send JSON payloads like very easily. FZF, which is the thing making that kind of fancy selection menu here. Tmux, tree, well, I like tree sometimes when you're like, hey, I just want to display the structure of a directory and the files in it. So you can do tree and it's going to show you something like this. Of course, Git. And then when you are using specific Kubernetes tools, like Flux, you know, Argo CD, Velero, you might want their CLIs as well. And the list goes on and on and on. This is like the list you see here, to be clear, it's not me trying to scratch my head about what tools could I use. No, that's the tools that I ended up collecting year after year and that I use regularly. I'm not saying I use them every day, but once in a while I'm going to use these tools for one thing or another. Like these ones are a bunch of like JSON and YAML manipulation tools. Oh, there is JLess also, which is also like super great to manipulate JSON. I don't even know if I have it here, so I can show you. I can do something like this. JLess is showing you JSON in the terminal the way you would see it in a browser console. So, you know, you can like, unfold, fold, etc. You can probably search maybe as well. Yeah, there we go. Really great. Tools to manipulate images on registries like Skopeo and Crane, and of course a bunch of other Kubernetes and cloud native tools. The list goes on and on and on and on and on. So, it would be nice if we could have an environment with all these tools pre-installed. And that's what I'm going to try to do. So just this morning, I deployed a Kubernetes cluster and I have deployed on that, sorry, I forgot to put the IP address. On that cluster, I deployed a tool that is called shpod, like shell in a pod, and basically it's a container that has a bajillion tools to work with Kubernetes and containers. Let me just type the password to connect here. Okay, so the way this works is that we have a Kubernetes cluster, and on that cluster, we are running, as you can see, almost nothing, but this shpod, that's the shell in a pod, and it's running an SSH server. So when I connect here with SSH, I land in that pod, and then this has been set up with permissions and so on, so that I can actually work on my cluster. I can look at the nodes, I can create a deployment, I can expose it, chip load balancer, and deploy blue. So anyway, I can do like normal Kubernetes things, and as you can see, I have this alias K, I have kubectl, I have crew, which is available, so I can install more kubectl plugins super easily. We have a ton of tools that are available in that container. Okay, great. Now, that's very quick example. Plus, if just in case, like, so what I'm trying to show here is that all I need to access that toolbox is an SSH client. So it's a pretty low bar. It doesn't matter if you are on Linux, on Windows, on a Mac. You could even be, you know, on an Android phone or tablet, or an iPhone or an iPad, any device with an SSH client. You can connect and you have all the tools available right there. And if you want to do some work, you know, like doing some things, okay, and I'm scaling this deployment, whatever, and suddenly like, oh no, I need to disconnect. Oh, I'm disconnected. Later, I can reconnect. And because I'm using tmux, I can reattach to the terminal exactly where I was, and I can resume my session with all my apps up and running. Okay, so this is great for terminal lovers, you know, who are super comfortable with the command line. Now, what if you prefer browser environments? You know, what if you're not super comfortable with VI and you would like something a little bit more user-friendly to edit your files? No problem. When we deploy that container, like that pod, there is also a web-based environment. I connect there. I don't know if you can see because it's a little bit small, but it's the same IP address as the SSH server. And basically, okay, I have to confess I'm not super good with that one, so I never remember. There we go, the shortcut to get the terminal. But I can explore my files. Yes, that one. And here I can actually edit files. As you can see, this looks like VS Code, right? But it's VS Code in the browser. And I don't use VS Code very often, so pardon me while I fumble around trying to find my, my way around this. Yeah, for instance, how do I get the, nope. How do I get the terminal again? Yes, like this. So I can do create namespace demo, and then if I want, I could change the namespace by editing that file here, namespace demo, save. And now if I go back here, you can see that my namespace changed to demo. Yeah, okay, I'm not going to go into a ton of details there. I just want to show, yep, if you prefer a modern editor like VS Code, which means you have all the extensions as well, you know, the Kubernetes extension and the Docker extension, etc. You can have that in that environment as well. All right. So the big advantage of that is, again, if normally when you pick up new tools, you're going to install them on your machine over time. You know, all the tools I was listing right there, like I did not install them just like overnight like this. It was kind of like day after day, after week, after week, after years. And now eventually I have all these tools, but if I go to a new machine or if I'm helping a customer or a student, they might not have all these tools installed. Or, you know, if I have to intervene on a cluster, but from a Bastion host or some air-gap environment, so basically I cannot access from my machine, I have to log into another machine. So the whole point here is to have an easy way to get my environment like really quickly. And honestly, the first reason why I built this was like this toolbox was for this use case. This is basically Kubernetes trainings and workshops back when you know, when conferences were a big thing. I mean, conferences still do exist, but we have less conferences than before the pandemic. But before the pandemic, I used to do a ton of conferences and trainings at conferences. So now it's no longer at conferences, it's generally doing live streams a little bit like this one. And that picture here is mostly for nostalgic purposes because it's one of the first live streams that I did during the pandemic. And I remember I had my laptop, you know, on a delivery, a cardboard box and multiple computers, and it was kind of a mess. So over time, of course, I refined that to have the setup I have today. But something that was very important back then and is still very important today is that for each student during the class, I would give them a dedicated Kubernetes cluster for the labs. You know, you're going to have like a 1 week or a 2 weeks training. And so during the whole training, each student have a Kubernetes cluster to do the labs, exercise, experiment with things, and so on and so on. So, and of course, I didn't want to give people, you know, like a completely raw, bare cluster. I wanted that cluster to be loaded with useful tools so that when I tell someone, hey, you can use like K9S or Stern or Tilt or whatever, I want the tool to be installed and available so that we can jump right into the interesting stuff. Which leads me to, you know, very brief sponsor block for myself because I'm the teacher of these classes. So in a couple of weeks, we're going to do a boot camp. So it's going to be a 2 weeks boot camp, 1 week on Docker and Kubernetes, and 1 week on advanced Kubernetes. So you can see it's like October 20th to 24th and then 27th to 31st. If you're interested, get in touch. And so basically that's going to be with the setup that I'm describing here. Each student gets their own Kubernetes cluster so that when you want to try something, you have a real cluster to try it out. And you might wonder, why do I need a real cluster? Can't I just use, you know, like a local Minikube or Kind or something like that? Well, you're right that when we do the fundamentals, you know, the basics, you don't need a fancy cluster for that. You know, if you're just creating a deployment and scaling up and maybe exposing it. But when we start doing auto-scaling, metrics, stuff like that, now you need a real cluster because you need multiple real nodes. Just to give you a tiny kind of a sound bite from that training, when we do cluster auto-scaling, the way cluster auto-scaling works on Kubernetes is basically when the cluster is full, then you scale it up, which kind of makes sense, right? Imagine you're moving, so you're filling a bunch of moving boxes, and now you have, you know, like something, I need to put this Raspberry Pi in a moving box, but all my boxes are full, then I get a new box and I put that in the box. That's exactly the way it works with Kubernetes auto-scaling. When you try to run a new pod, but all the nodes are full, or to say it differently, the pod doesn't fit on any node, then it's going to scale up the cluster, add a new node. And to do that, you need to have a real cluster, not just a bunch of containers that you run locally in Docker, Docker Desktop, Podman, and so on and so on. Okay, so end of our sponsor block and back on topic. Excellent question. Can I share how I initially create these Kubernetes clusters? Yes, absolutely. So I do have a repo. So, whoops, that doesn't work, okay. So on GitHub, so I don't know if I will be able to share a link, because on YouTube, if you just share a link like this, often it assumes that you're just sending spam, but I'm gonna try. So prepare labs, and then in there, the interesting bit is in Terraform. So I'm gonna try to send that link to the chat. Don't know if that's gonna work or not. So that link is specifically in my training repo to the directory that has all the Terraform configurations to create a bunch of clusters. And so, for instance, one Kubernetes, there we go. This is if you want to have managed Kubernetes on all these providers. So we have AWS, DigitalOcean, Google Cloud, Linode, Scaleway, OVH, so a bunch of providers. Plus, we have something called vCluster, which, well, maybe you already know vCluster, but it's a little bit like virtualization for Kubernetes. What I mean is that when you have a real Kubernetes cluster, you can create virtual clusters on top of it, and for some classes, that's also super convenient. All these Terraform configurations are usable standalone, so you can go to any of these directories and do Terraform plan, Terraform apply, and it's going to spin up a cluster. But they are also used as part of a bigger, I'm gonna say, a kind of harness, where there is a script where you can say, start me 80 clusters on Linode in US West, go, and it's going to do it. So if you want to run a bunch of clusters, that's fine. Great question. What if you want an unmanaged cluster with VMs? Well, guess what? I also have that if we go to virtual machines. So it's a different set of providers, just because basically I wrote those when I had requests from customers. Sometimes a customer would tell me, hey, for the class, can you teach us on Azure, because that's what we're going to use? And I'm like, sure, let's provision the stuff on Azure. Between us, it's going to work exactly the same way, but sure, you're the customer, you're the boss, you want to work on Azure, we're gonna work on Azure. So I also have scripts to provision a bunch of VMs and then put the VMs together with kubectl. So then you have kubectl clusters. It's fairly basic, but that gives a different vibe and experience, sort of. And same thing, same scripts, you have different invocation, but you're like, hey, create, for instance, 30 clusters with 4 nodes each on that thing, and that works. All right, so that's my use case. I want to be able to create these environments. Now, how did I do that? Well, the idea was I made a container image, so that's spod, and spod, so that means shell in a pod, and in spod we have, okay, so this is, at some point I gave a talk at a local meetup, and I think the title was the ugliest Docker image I've ever built, and it was that one, because the Docker file has like almost 400 lines. It has about like 30 stages, because that's the Docker file putting together that image. And so it's building a bunch of things, it's putting all the binaries together, it's embarking an SSH server, but also the code server, like the VS Code in a browser thing. So that's a pretty complex image, and honestly, I think we could also do a talk like just about that image, because there's a bunch of whoops, why is this not working as it should? Sorry, there we go, yeah. So we could do also a talk just about that image, because there are a lot of interesting patterns in there. There is multi-stage, there is multi-architecture, because it works on Intel and ARM, etc., etc. So, there are multiple ways to use that image. For instance, if you're just doing Docker stuff, you can mount the Docker socket in the container. And so now in the container, if you use Docker commands, it's going to use the Docker socket on your machine. Or it might look a little bit complicated if you're not familiar with Helm, but basically what this is doing is installing a Helm chart that comes from this Helm repo, and then by default, when you start your fancy dev environment, by default it will not have any permission. So when you connect to it and you do like kubectl get nodes, by default it would tell you something like, sorry, you have no permission to list nodes, go away. So that's why we have that extra line here, which means, hey, I'm using Kubernetes RBAC, role-based access control, to give permissions, more precisely to give cluster admin permission. And then that way you can do everything you want in your dev environment. So it's just a little detail, but like, why? I didn't want to publish a Helm chart which would give a ton of permissions if you're not paying attention. You know, if you just install the Helm chart without thinking, no, I didn't want to open any kind of backdoor or security hole or whatever in the cluster. So by default, it opens a server, but no permissions in there. So that's why you need that one extra line here to say, hey, I want an environment and I want permissions in that environment. Small detail, but I imagine the security team might appreciate that. And then the two extra lines below are kind of optional. The kubectl wait here is just to wait for the deployment to be up and running. And then the kubectl exec here is to just like spawn a shell in that environment. Okay, now, you were asking just before, like, hey, how do you provision a bunch of clusters? And this is an example. So, yep, basically, how do I create 25 managed Kubernetes clusters on whatever provider? Well, of course, you need to have set up the provider credentials. So, you know, maybe in environment variables or .config files or whatever. Yeah, that's it. All right, so, and then yeah, at the end you get, at the end it's going to output not a CSV, but okay, internally it's using a JSON-L, you know, like a JSON in line by line, and in the script there is something to convert into TSV, tab separated value, so that you can directly copy paste it in a Google Sheet. So you have the Google Sheet with the right format, you paste and boom, you get exactly that, and you can share that with the students. Anyway, that's kind of off topic. So let's move on a little bit. Some questions that some folks asked is, hey, why don't you just create one namespace per student? It would be way easier than giving a whole cluster to each person. And yes, you're right. If you just want to do the basics of the basics, the bare fundamentals, namespaces are great. You can create deployments, services, stateful sets, and whatnot. But once you want to demo how to work with namespaces, how to deploy the same app with different like configuration variations, how to install operators, custom resource definitions, metrics. You can't do that if you only have access to a single namespace. So that's why I think that for real, Kubernetes classes, it's really important to have your own cluster. You probably know about a lot of platforms like Killer Coda, Katacoda, Play with Kubernetes, and so on, and they are great, they are pretty awesome. However, they don't really fit the stuff I want to do because most oftentimes, these platforms are either free or very expensive. So either they're free, but then the environments have a really short time span because you can't just give free compute to everyone like this. And so if I teach a 1 week or 2 weeks class, that's not great. And also very often these are competitors. So like I teach Kubernetes classes. I'm not gonna teach my classes on learnkubernetes.com or something like that. And so like I was saying, either they're super cheap, well, free, or they are very expensive. If you're like, hey, I want to use your platform, but I would like to have clusters that I can keep for 2 weeks and something a little bit bigger than the best stuff you have, suddenly the bill gets really, really expensive compared to running your own. All right. So, I'm listing other ways to deploy these clusters, but I'm going to focus on the dev environments. So yeah, I mentioned you can connect in that dev environment with SSH, but you can also connect with the browser because, well, so okay, the impetus for that, the reason was that in the beginning, when I was teaching my Docker and Kubernetes classes, most of the folks were already, pretty advanced. They were like senior DevOps and so on, who were super comfortable with the Linux command line. And when I said, hey, we're going to SSH on some VMs and use VI, they were like, yep, no problem. And then over time, I also started to have more diverse folks, like developers who maybe did not have strong Linux experience. And when I was saying, hey, we're going to SSH and edit files with VI, they were like, not cool, teacher. So after a while, that's how I added the VS Code in the browser thing. Also I had some people ask me, hey, can you use AI? And this is an actual screenshot from that happened once where we're like, hey, I don't remember I think it was maybe with Copilot, but basically we were like, okay, we want to I don't even remember if we are trying to remove the container or remove the service. And this is what happened. You start typing remove the, and AI completed with remove the chicken from the oven and let it rest for 5 minutes. And like, what? And it may or may not have been because we're working on a project to generate cooking recipes. And so I think maybe Copilot got hungry and started to, babble about chickens and ovens and lemon wedges instead of talking about how to remove the container from the environment. Anyway, I tried a bunch of different things, For instance, I thought about, hey, what if I just give people a kubeconfig file and I'm like, take that kubeconfig file and that way you can access your Kubernetes cluster. That doesn't work because you need to still install kubectl and maybe helm and maybe K9s and Stern and all the tools that we need. So we're kind of back to square one. Then I thought, some people suggested, and at first I was like, oh yeah, great idea. Why not use VS Code extensions? So you have VS Code extensions so that you are in your VS Code and VS Code connects over SSH to a remote environment and you can edit remote files. For reasons, the SSH extension to VS Code requires to have the proprietary build of VS Code, and it took me like days to figure this out because I thought I was getting crazy because I was following a tutorial, like a video, like step by step, and they were like, and now you go to extensions and you install the SSH extension. It's like, well, there is no SSH extension. What are you talking about? Turns out I was using an open source version of VS Code, and if you want the SSH extension, you need the proprietary version of VS Code for reasons, I guess. Maybe they fixed that now, but a couple of years ago it was like that, and after a couple of days I was like, okay, VS Code, stop gaslighting me, this is not a good option, and so that's how I ended up with this idea of VS Code in the browser. So then of course you do a bunch of research. There are many options out there. I picked Code Server just because it's the first one that I got to work sort of reliably, but I also tried Thea, I don't know how to pronounce that, Eclipse, Jupyter. They all have their pros and cons, strengths and weaknesses. Typically, if you want to do dev stuff, Jupyter is awesome. Like I use it sometimes to teach Python classes. It's so good. But for DevOps Kubernetes stuff, I like using Code Server. Okay, and so the results, the outcome, like the deliverable, the stuff that you might want to use for your own stuff. So there is that spod image, which has all the tools plus VS Code and so on. Oh, and by the way, that spod image comes in multiple flavors, multiple tags. There is kind of like the base version that has all the tools and an SSH server, and then there is the version which I named VSPod, which has Code Server. And I made a separate version because Code Server is pretty big, and so I wanted to retain the option of having a smaller image. So it's all open source, you know, like everything on this public GitHub repo. So you can absolutely like take that image as is or rebuild your own, add your own tools, remove tools if you think I made terrible decisions with some of the tools. You have the option of running code server in the same container or in a separate container. It also pre-installs the Docker and Kubernetes extensions because one thing I've noticed, and again, if you're not teaching classes, you wouldn't know. I didn't know, but if you're like, hey, we're going to use these extensions, then for a few minutes, everybody is like looking for the extensions and installing them. And sometimes it's a little bit tricky because, for instance, not so long ago, I gave a workshop on Spring AI, and I remember when I did it for myself, you know, I was, confession time, I'm not really a big Java person. The last time I had done some Java was in college, which was maybe 25 years ago. But so recently I paired with a Java expert, and so we did a Spring AI workshop. She was bringing the Java side, I was bringing the container side, and that was great. But when we set up my environment, we were like, okay, install extension. That was like Spring, and there was maybe, I don't know, half a dozen extensions, and she told me, pick that one. So I just picked it. But then we realized once you are in front of 50 students and you're like, oh, install the Spring extension, and they're all like, which one? There is a million of them. So this also, small detail, but helps a lot, pre-installing the extensions. And if you want to pre-install your own extensions, it's also super easy. Sorry, let me show you. But in the Docker file, at some point towards the end, there we go. You can see here, install extension MS Azure Tools VS Code Docker. Okay, so I guess you can guess, like all you need to do is go and find out what's the kind of like code name for my extension and just add it here in the Docker file and you're golden. Okay, so this is something that I use for literally all my Docker and Kubernetes classes. That image gets a lot of usage. It's updated once in a while. So, you know, it's not just something I made for fun. It's used in production. So I put quotes around production because it's not production like, yeah, we're doing 1 million requests per hour. No, it's production in the sense that each time I teach a class, I have students using that image, you know, connecting with SSH or with code server in Kubernetes clusters. So it's used by actual people doing actual things. So now, of course, you're not my students, or maybe not yet. So you might wonder, okay, what's for me in this? Like, is there something that could be useful for me? Maybe if you are working with very light environments, you know, like iPads, Chromebooks, things like that, that could be a way to have a good Kubernetes environment. Another thing that I've noticed is for pair programming. You know, if you, I'm sure you know the idea of pair programming. We're going to put more eyes on the problem. And if you are sitting on the same desk in front of the same screens, that's really easy. But when you are doing remote work, it can be a little bit trickier. Of course, you can do screen sharing. But the nice thing with pair programming is that you can literally hand over the keyboard to the person sitting right next to you. And with that, you actually can, you know, if you're using that Tmux thing I was showing you, you can have multiple people sharing the terminal. That's really great for doing pair programming in the terminal. And same thing with that VS Code. So that's also a good use case for that. And yeah, that's what I was that's what I wanted to talk about. Before, yeah, I'm going to take questions. I tried to address the questions as they were coming in, but if I missed your question or if you're not satisfied with my answer, feel free to ask it again or to ask new questions. And before questions arrive, I'm also going to mention again that at the end of the month, at the end of October, we're going to have a boot camp, like a 2 weeks boot camp on Docker and Kubernetes. The first week is going to be Docker and Kubernetes foundations, and the second week is going to be advanced Kubernetes, like Kubernetes production stuff, everything about like requests and limits and airbag and gathering metrics and auto-scaling and CRDs and operators and so on and so on and so on. There we go. So yeah, that's it. So do you have more questions? So I saw someone say it would be cool to have that conversation. If I remember well, this is when I was talking about the spod image and how I built it. So point taken. We could totally have another live stream in a little while to talk specifically about how to build that kind of image. And like spoilers, there is a lot of stuff going on here. I think we have maybe 28 stages. Sometimes we download binaries, sometimes we build them, sometimes we build Go, sometimes we build C. At some point I had put something in Rust, but I don't remember if I kept it in the final image. So lots and lots and lots of things there. So yeah, we will that's an excellent idea and question. We will absolutely have a webinar to talk about that spod Docker image and show like some of the cool patterns that I'm using there for multi-arch to parallelize the build, automate the build on GitHub Actions, all that kind of stuff. Yep, absolutely. I'm going to write that down somewhere as well. Any other question, suggestion? Yeah, this is the t-shirt I put when I teach. It's day 2 of Kubernetes fundamentals, when we're like starting to generate YAML manifests, and so that's the XMLORSys t-shirt. All right, well, thanks everyone for joining. I hope this was useful for you one way or another. Oh, can I give a one-liner on each tool I have installed from slide 7? I suppose you mean an example of use for all these tools. So let's see. So trying to think about, okay, I showed kubectl and kubeNS, right? That was the thing to switch namespaces like this, or switch context to different clusters. Kubecolor, we saw it in action. That's the thing that's colorizing the output. Oh, and by the way, it's colorizing the output, but it's also being smart about it. What I mean is that if I do this, it's not obvious, but it's actually using a different color set depending on whether you have a dark terminal or a clear terminal. So there's some hacks to make that happen. What else? Curl. Okay, I think curl is super well known, so I'm going to skip that one. HTTPy. I'm gonna be honest with you, I don't know if I would be able to give an example of HTTPy like this, but basically when I need to post an HTTP request, with a JSON payload, that's my go-to tool for that. I already showed tmux and tree. I'm not going to demo Git because everybody knows Git, hopefully. Flux and Argo and Velero, I can't really give a one-liner because these are CLIs to manage Flux, Argo, or Velero backups. JQ, yeah, JQ I can definitely show you something. So for instance, if you do get nodes dash o JSON, you have a JSON output, and with JQ, we can kind of like parse that output. Okay, give me items. Here, give me the names of the nodes, or give me, is it spec.capacity? No, it's maybe status.capacity. .cpu. Okay, and I can see how many CPUs I have on my nodes. Except that's not very nice. Give me the name of the node. Okay, and the capacity. So metadata.name status capacity CPU. There, whoops, close the quote. There we go. Now put that in TSV format. And whoops, pipe at TSV. And finally, let's put that, I don't have columns. Okay, maybe I don't have columns and I don't know in which package it's gonna be. Okay, that was worth a shot. But yeah, that shows me like the nodes and how many CPUs they have. So that's JQ. YQ is doing the same thing, but with YAML input, and actually what it's doing is converting the YAML to JSON and then executing JQ. JID, it's also something to manipulate JSON. There is another one that I showed you earlier, which I actually like better than JID now, which is JLess. Gron. Oh, Gron is super dope. With Gron, basically, you transform JSON in this kind of like flat thing. You know, you're like, hey, okay, for instance, let's do that on a slightly simpler object, you know, like this namespace object, Gron. And let's say I want to get rid of the status, so I can do a grep-v json.status and then gron --ungron, I think. There we go. And so it transforms back the gron format into JSON. Just in case that wasn't clear, what I did here is take the JSON for the namespace and remove the status field. And this is like very convenient if you want to do some transformation on the JSON, you know, like, I want to change that particular label. That's super convenient, you know, like then you can use stuff like grep, sed, and so on to transform the JSON. Awesome sauce. Skopeo and crane, this is to manipulate and download image, and actually that one I haven't put in the image, but it's available in packages. So skopeo, copy, let's say I want docker ://alpine, and I want you to put that into OCI alpine.img. So this is going to download an image, so in that case the official Alpine image, and put that into that alpine.img directory, and then you can do stuff like, hey, right, get the blobs, so blobs sha efc. Okay, that's the image manifest. Now I want to get the layer here. So 98 something, 98 something, and now if I want, I can extract this in alpine.root. There we go. Whoops, nope, that didn't work. Right, right, because I'm using the tar from Alpine, and it might not have the -c option, or maybe I'm not using it right, but anyway, this is supposed to decompress the file. Is it actually doing that? Alpine-mg, Alpine root. No. Oh, sorry, I forgot the F, so it was expecting something on stdin. My bad. And so I just uncompressed an image manually, without using Docker or whatever. Skopeo can also be used to do some image surgery, so to speak. I have an example. I'm going to try and put the link in the chat. I don't know if that's gonna work, but you can see it's on GitHub. It's called layer remove. It's an absolutely horrible Python script to take an image and remove a layer. And so the way you do that is that in the Docker file, you put a comment in the layer like this. You put like hash layer remove hash. And so the Python script is basically taking the image, looking at the layers, and when it sees a layer with hash layer remove hash in the comment, it removes the layer. Should we do that in production? Probably not, but basically a few years ago, somebody asked me, is it possible to do that? And at first I was like, no, you can't do that. And then I was like, what stops us from doing that? And so I took Skopeo to do it. What else? Crane, very similar to Skopeo. Tilt scaffold, that's going to be a little bit difficult to do a one-line example. Helm file, same thing. Let's see if there is another one that could be... yeah, everything else that would take a slightly longer demo here. I'm just going to give a mention to Bento because it's like extremely cool. Bento is when you want to process message streams. So for instance, you want to read from a Kafka topic or a queue in Redis, and for each message, you want to post that on an API, or you want to make it easy to consume message from a Kafka queue with curl. And so then you could use Bento to say, hey, you are going to expose a web server, and each time somebody makes a request, you're going to get a message from this Kafka queue and send that as the response body. And all that with like 8 lines of YAML, basically. Extremely cool. If you do any kind of message processing, seriously, look at it. It's great. All right, well, I'm so sorry that I couldn't give one example for every single one of them, but I hope there was, some examples, some things that, ideally, at least I hope that there was one of these tools where you thought, I didn't know about that, and I feel like this is going to save me some time or make my life easier. If you got that from today's live stream, that's great. Now, if you are also excited about Kubernetes development environments, that's even better. But honestly, I think when I put that presentation together, I was thinking, at least with the tools, I hope there was going to be at least one tool for everyone to kind of like bring back home and level up in your DevOps and container practices. All right, that's it. Thanks once again. We are going to have more of these live streams in the future, at least to talk about that Spot image. I wish you a wonderful rest of the morning, day, afternoon, evening, night, depending on your time zone. And we'll see you next time. Thank you.